Hello everyone, I am Dr. Raman. Welcome to my channel Professor PG Raman. Now today we are going to discuss with contour integration problem. The type is semicircle. Now see the problem. Evaluate 0 to infinity integral over 0 to infinity dx by x square plus a square into x square plus b square, a greater than 0, b greater than 0 by using contour integration. Now first of all, the previous problem, when we can apply with the semicircle condition type, mainly important minus infinity to plus infinity, because of see this is a semicircle, minus r to plus r. This semicircle is nothing but S is semicircle 0. This is a condition x y. So integral over c f of z dz equal to minus r to r f of x dx plus s semicircle f of z dz to apply with this condition. But the problem is, given the given problem, minus infinity to plus infinity is not given. So when is given minus infinity to plus infinity, we can apply with the direct this condition. Easily we are going to solve. But the problem is, here it's not given minus infinity to plus infinity, is given only 0 to infinity. So first our main aim is this 0 to infinity convert into minus infinity to plus infinity. How to convert? Using odd function, even function. So when minus infinity to plus infinity, minus 1 to 1, minus 2 to 2 and so on, then we can check with the function is odd function or even function. How to check? If odd function is nothing but f of x, x to replace minus x, minus f of x, then it's a odd function. The odd function value minus infinity to plus infinity, f of x dx equal to 0. So what are the odd function value? For example, x, x cube, x power 5 and so on. These are the odd function. Sin x also odd function. And then even function, f of x, replace x to minus x, then the value again f of x even function, minus infinity to plus infinity f of x dx equal to 2 times of 0 to infinity f of x dx. So this is a even function. For example, x square, x4, x6. So these function values are even function. Cos x, modulus of x, sin modulus. So these are the even function. Therefore here now integral over infinity, minus infinity to plus infinity dx by x square plus a square, x square plus b square. Look at here, when I replace x to minus x, again it's x, therefore it's a even function. When is a even function? This is also even, this is also even. When the even function, now we should write in form of 2 times of 0 to infinity dx by x square a square into x square b square. But the given problem in the form of the right hand side. Therefore 0 to infinity dx by x square plus a square, x square plus b square equal to this 2 to take with left hand side. Therefore 1 by 2 minus infinity to plus infinity dx by x square plus a square, x square plus b square, to solve this function. So now here to consider, this is the equation number 1. Now let consider integral over c f of z dz equal to integral over c f of z to replace this function to z function. So dz by z square plus a square, z square plus b square, because let this is a whole term f of z. F of z equal to 1 by x square plus a square, x square plus b square. This is a f of x. Now consider x to z. Now dz by z square plus a square, z square plus b square. Now what is a Cauchy residue theorem? Cauchy residue theorem, integral over c f of z dz equal to 2 pi I into sum of the residue at the point z1, z2, z3 and so on zn. So this is a Cauchy residue theorem. Now integral over c f of z dz equal to, this time 2 pi I into sum of the residue. Therefore now to find this term, so 2 pi I into sum of the residue. Now first to calculate poles, first to find poles. How to find the poles? Denominator equal to, the whole denominator equal to 0. Therefore z square plus a square, z square plus b square equal to 0, z square plus a square equal to 0, z square plus b square equal to 0, z square equal to minus a square, z equal to plus or minus ia. Here z square equal to minus b square, z equal to plus or minus ib. So this is our poles. So the poles is nothing but z equal to ia minus ia, ib minus ib. So we have 4 poles. 4 poles. Now check these poles are inside the circle or outside the semicircle. To check, these points are inside the semicircle or outside the semicircle, minus infinity to plus infinity, and then this is a semicircle, y and then x. For this term x equal to z equal to ia. Now what is mean this? Z equal to means x plus iy equal to ia. From this equation x value 0, y value a. Therefore now to consider x 0, y a. Now suppose I consider this is a, this point 0 comma a. Therefore this z equal to ia, this is a simple pole. Z equal to ia is a simple pole lies inside the semicircle. Yes. Then z equal to minus ia. So minus ia is nothing but x plus iy minus ia. From this point x 0, y minus a. So when I check this, consider minus a, 0 comma minus a. Therefore z equal to minus ia is a simple pole lies outside the semicircle. Yes. And then z equal to ib. So z equal to ib, the value is nothing but z x plus iy equal to ib. From this equation x 0 yb. So x 0 yb, to check this point 0 a b. Suppose a b moving, so 0 comma b. Now z equal to ib is a simple pole lies inside the semicircle. Yes. Then z equal to minus ib x plus iy equal to minus ib x 0 y minus b. In the semicircle point, this is a minus b, 0 comma minus b. Now z equal to minus ib is a simple pole lies outside the semicircle. Yes. So therefore here z equal to, what is the condition? Z equal to IA IB inside the semicircle, z equal to minus IA minus IB outside the semicircle. So therefore when simple pole at the point z naught, then finding the residue equal to limit z tends to z naught, z minus z naught, f of z. So let f of z is nothing but f of z equal to dz by, so yes, 1 by z square plus a square, z square plus b square. So now rewritten in the form of factor. What is a factor? Z plus I a. So now z equal to ia. So z minus ia, z minus ia, z plus ia, z minus ib, z plus ib. So now this is a f of z. Now the first point, z equal to ia, I will take any order to take. So z equal to ia. Now residue 1 equal to limit z tends to ia, z minus ia into f of z, 1 by z minus ia, z plus ia, z minus ib, z plus ib. Now to cancel this two term, now substitute z tends to ia here, here, here to substitute. Therefore when I substituted, ia is 2ia, then ai minus ib, ia minus ib, and then 2ia, sorry, this is ib, this is a ib. Therefore here ia plus ib. Therefore this is a 2. So therefore this term ia by I. So a minus b, a plus b is nothing but a square minus b square, a square minus b square. Therefore this term should write in the form of 1 by 2ia, ia square minus ib square, a minus b whole square, a square minus b square. So I square value minus 1, therefore 1 by 2ia, I square minus 1 minus a square minus I square minus 1 minus of minus plus b square, I square b square. So minus of minus plus. Therefore this term, so when I am taking minus, so multiply with here, when I am taking minus common, minus 1 by 2ia, a square minus b square, this is a residue 1. Then the residue 2, z equal to minus ia or to 0 since this point outside the semicircle. Now z equal to ib, therefore the residue equal to limit z tends to ib, z minus ib into f of z, z plus ia, z minus ia, the first term z minus z plus, so z minus ia, z plus ia, z minus ib, z plus ib. To cancel this two term, therefore here in this term, this two term, a minus b, a minus b, a plus b is a square minus b square. Therefore limit z tends to ib 1 by z square minus ia whole square. When I substitute I tends to ib, so when I substituted this term z plus ia, when I substituted I, z tends to ib, therefore 1 by ib minus ia, ib plus ia, then ib is 2ib. So this term is a minus b, a plus b, a square 1 by ib square minus ia square, a square minus b square into 2ib. So this is I square b square, I square a square 2ib. I square value minus 1. Therefore, so this is a term 1 by minus b square, minus of minus plus a square 2ib. Therefore 1 by 2ib, a square minus b square, this is a or 3, residue 3. Now residue 4, z equal to minus ib, residue 4 0 because of z minus ib outside the semicircle. Now the previous part, see, integral over sf of z. Now to consider, this is the equation number 2. So from 2, so from 2, integral over c f of z dz equal to, so integral over c dz by z square plus a square, z square plus b square equal to 2 pi I into sum of residue r1, r2, r3, r4. Therefore 2 pi I into residue 1 value, residue 1 minus 1 divided by 2ia, minus 1 by 2ia, a square minus b square plus 0 plus 1 by 2ib, a square minus b square plus 0. So therefore to take common term 2 pi I, here 2i common, therefore 1 by 2i I am taking out, then a square minus b square common I am taking out, so here minus 1 by a plus 1 by b, so minus 1 by a, 1 by b. So this term 2i cancel, therefore pi by a square minus b square. When I am taking this LCM, minus b plus a by ab. Therefore, this term should write a square minus b square is a minus b, a plus b into a minus b by ab. Now cancel this a minus b, a minus b. The term is pi by ab into a plus b. This is the integral over c f of z dz. Now from 1 and before that, from 1, integral over 0 to infinity dx by x square plus a square, x square plus b square equal to 1 by 2 minus infinity to plus infinity dx by x square plus a square, x square plus b square. So now what is the condition? For the condition when the condition integral over c f of z dz and then minus infinity to plus infinity, that is a real number, minus r2 plus r f of x dx, then semicircle f of z dz. So if r tends to infinity, then integral over c f of z dz equal to minus infinity to plus infinity f of x dx plus this term 0 when r tends to infinity. If r tends to infinity, then integral over s f of z dz tends to 0. For here minus infinity to plus infinity f of x dx, this is a value, so integral over c f of z, so dz by, now the answer is nothing but pi by ab a plus b, a plus b. So from the equation number 3 by 3 equal to minus infinity to plus infinity dx by x square a square, x square b square. But when this condition to replace with 0 to infinity, see here, when the condition is 0 to infinity, minus infinity to plus infinity, when the condition to replace 0 to infinity, multiply 1 by 2. So when multiply 1 by 2, the value will be changed immediately. So here multiply 1 by 2 means both side, when we are multiplying 1 by 2, the value will not change. Therefore 1 by 2 pi by ab a plus b equal to 1 by 2 minus infinity to plus infinity dx by x square plus a square, x square plus b square. Now this term should be a value of 0 to infinity dx by x square a square, x square plus b square. Now this term pi by 2ab a plus b, 2ab a plus b. Therefore the final answer 0 to infinity dx by x square a square, x square b square equal to pi by 2ab a plus b. So this is your final answer using contour integration. Thank you.